Hello students, this is a video on the topic test that we have at Bodhee Prep for you. These tests are designed or they aim to help you gauge your preparation as you complete topics as part of your preparation. So once you've gone through the basic concept, that is when you take this test. Once you've taken a test, you look at the video and you will get to know the solutions and an analysis of what could have been a good attempt, which questions could have been attempted, and the time that you should have put for different questions. If you do like the test and the analysis, there are more than 200 such topic tests available on our Android app. The app for the link of the app is in the description of the video. So you can just download the app and start making use of these tests that we have for you. This video is on number systems. The concepts or the topics covered are factorial, cyclicity, and the base system. And this is the first test on these topics on the app. Overall analysis for this test will be, this is a easy level of difficulty paper, and about 7 to 8 questions would have happened easily, and the attempt time should be somewhere around 18 to 21 minutes, because there were very few questions where cases were being made as such. If you look at the questions, question number 1 says, if a 6-digit number, in a 6-digit number, 1, 2, 3, 4, 5, 6, the sixth, that is the rightmost digit, this one, is the sum of the first 3 digits. The fifth digit is the sum of the first 2 digits. The third digit is equal to the first digit. So if the first digit is x, the third digit is x. Third digit is equal to the first digit. Second digit is twice the first digit. So the second digit is twice of x. From here we can write the sixth digit, which was the sixth is the sum of the first 3, x plus 2x plus x, which is 2 plus 3 plus 4x. The fifth digit is the sum of the first 2. So x and 2x, sum is 3x. And the fourth digit is the sum of the fifth and the sixth digits. 3x plus 2x, this digit is 7x. So the number is x, 2x, x, 7x, 3x, 4x. Largest possible value of the fourth digit. Now this digit has to be a single digit, and the values that it can take is anything from 0 to 9, including both. But if you look at 0, then this number will not remain a 6-digit number. So 0 is not included. 7x could have a value from 1 to 9 per se. It is a multiple of 7. If you put x is 2, this becomes 14, which is not possible. So the only possibility is x is equal to 1, in which case this number will become 121734. Anything more than this is not possible. The largest possible value of the fourth digit is, it is simply 7, and that becomes the answer. This is an easy question. Not more than 90 seconds to solve this. Basic application of the decimal base system. If a number is written as 100, 100, 100, and so on in base 2, how will it be written in base 8? Now, if we want to go from base 2 to base 8, what we can do is we can convert base 2 into base 10, and then from there go to base 8. Conversion into decimal and conversion from decimal are standard processes. But when we are talking of 2 and 8, because 2 cube is 8, 3 numbers in the base system will represent one number in base 8. That is 0, 0, 0 in base 2 will be 0 in base 8. 0, 0, 1 will be 1. 0, 1, 0 will be 2. 0, 1, 1 will be 3. 1, 0, 0 will be 4. 1, 0, 1 will be 5. 1, 0, 1, 1, 0 will be 6. 1, 1, 1 will be 7. The moment we use 3 complete digits in base 2, that covers one complete digit in base 8. So what we can do is we can make groups of 3 and look at the corresponding value in the 8 in the base 8 system. Now 110 in base 2 will correspond to 4 in base 8. So this becomes 4, 4, 4, 4, 4, 4, 4. So if this is the binary number in base 8, this will be the equivalent in base 8 will be 4, 4, 4, 4, 4, 4, 4, which is option A. So again, a direct application of the base system. If we have covered base system, this should not be a difficult question to solve, and therefore easy question, 90 seconds. At an island, people use a number system to base n such that n is less than 9. Which of the following is true of the remainder obtained when an inhabitant of that island divides 11111 n times to the base n by n plus 1? We will take two cases because of odd and even. Let n be 6 or n be 5, and we will see what the remainders are. So here we'll get 111 111 6 times to the base 6. Let us convert it to the base 10. So this 1 will get multiplied by 6 raised to power 0. The 1 before this by 6 raised to power 1, 6 raised to power 2, 6 raised to power 3, 6 raised to power 4, and then 6 raised to power 5. We are dividing this by n plus 1, which is 7. Now, if we divide n raised to power x by n plus 1, the n plus 1, n can be written as n plus 1 minus 1 raised to power x divided by n plus 1. So the remainder here, n plus 1 will divide, the remainder will be minus 1 raised to power x. If x is odd, remainder will be minus 1, x is even, remainder will be plus 1. Now, if you look at here, there are even number of terms. From the first part, because here x is odd, we'll get remainder as minus 1. Then remainder is plus 1. Then again minus 1. Then again plus 1. Then again minus 1 and finally plus 1. These numbers will cancel out to give us a remainder of 0. So if n is even, we will have even terms and the remainder will be 0. If we look at n is equal to 5, 1, 1, 1, 1, 1, base 5, converting this into bases, now we'll get odd number of terms. 5 raised to power 0, 5 raised to power 1, 5 raised to power 2, 5 raised to power 3, 5 raised to power 4. Multiplying each term with an increasing power of 5, this divided by 6. The first term will give a, from this logic, first term will give a remainder of 1, then minus 1, then 1, then minus 1, and finally last one will give us a remainder of plus 1. Here the number of terms are odd. So net 1 will always remain. So when n is odd, remainder will be 1. From the options, it is 0 when n is odd. No, it is not. It is 1 when n is even. No, it is not. Both a and b are true. No, it is not. Neither a nor b is true. Yes. So option D becomes the answer. Again, application of base, but overall, I'd say it's a moderate level of difficulty where you have to understand basic concept of remainders as well. From there on, 2.5 minutes should be good enough to answer the question. What are the last two digits of 7 raised to power 2008? 7 raised to power 1 is 7, 7 raised to power 2 is 49, 7 raised to power 3 is 343, 7 raised to power 4 is 2401. Because we get 01 in the end, if you look at the last two digits, this pattern will repeat. 07494301, then again 07494301 and so on. This happens with the powers of 7. Now 2008 is nothing but 7 raised to power 4 into 502. So basically it is a 2008 is a multiple of 4. So we look at the fourth power which ends in 01. Hence 01 will be the answer. The last two digits of 7 raised to power 2008. Because we are looking at 7, I'm saying this is an easy question based on cyclicity. Simply looking at the pattern, we get the answer. Hence 90 seconds should be good enough to solve the question. The rightmost non-zero digit of 30 raised to power 2720. Now, when we expand this number, we will have zeros in the end because of this 0. The rightmost non-zero digit will happen because of 3. So basically, the rightmost non-zero digit of 30 raised to power 2720 will actually be the last digit of 3 raised to power 2720. So basically, we're looking at cyclicity of 3. 2720 is divisible by 4, 20. The last digit of 2720 will be the same as the last digit of 3 raised to power 4, because unit digit cyclicity for any number is to the power 4. It repeats after 4 powers. 3 raised to power 4 ends in 3 raised to power 1 is 3, 3 square is 9, 27 and 81. So 3 raised to power 4 ends in 1, and therefore the last digit of 3 raised to power 2720 will also be 1, and that will be the rightmost non-zero digit of 30 raised to power 2720. Option A becomes the answer. Single digit cyclicity, and therefore also it's an easy question. All you have to do is divide the power by 4 and look at the remainder. So easy question, not more than 90 seconds to solve it, provided we've done the topic before taking the test. If 6 to the base n1 into 7 raised to the base n2 is 33 to the base n2, where n1 and n2 are bases, so that n1 is less than equal to n2, how many different values can n1 assume? Let's convert everything into base 10. This will become 6, this will become 7, gets multiplied by n1 raised to power 0. This also gets multiplied by n2 raised to power 0. This will become 3 into n2 raised to power 1 plus 3 into n2 raised to power 0. n2 raised to power 0, n2 raised to power 1. So now we have the equation in decimal. So 42 is equal to 3n2 plus 3, which means 3n2 is 39, which means n2 is equal to 13. Now n1 is less than or equal to n2. So n1 could be 13, it could be 12, 11, 10, 9, 8, 8. Could go to 7 as well, but not less than 7 because the digit 6 has to be available in N1. So N1 has to be larger than the digit that is used. So N1 cannot be 6 or less than that. Therefore, the values N1 take is 1, 2, 3, 4, 5, 6, 7. 7 values is what N1 can take. I'd say moderate level of question based on basis. If you understand the concept of base, we should be able to do this in about 2 odd minutes. What is the largest power of 2 that can divide 269 factorial? Now, this is a standard process that we follow. We start dividing by the number for which the factorial is there by the prime number for which the power is to be calculated. So we start dividing 269 by 2. This is divisible 134 times. 134 by 2, 67 times. 67 by 2, we write the largest GIF of the value that we are getting. This will be 33. 33 by 2 will be 16. 16 by 2 would be 8. 8 by 2 will be 4. 4 by 2 will be 2. And 2 by 2 will be 1. 67 plus 30. Add all of these numbers to get the answer. 100 plus 134, 234. 67 plus 33, 100 plus 1, 234. 234, 4, 5, 6, 7. 7, 8, 15. 15, 6, 31. So the total becomes 265. So 2 raised to power 265 will divide 269 factorial. Largest power of 2 that divides is 265. Again, since it's a direct formula or process-based question, so I think this is something that you should be able to repeat. The only reason I'm saying this is a moderate level of difficulty is because there might be a calculation error that can happen. The rest, it should not be a question that you'll not win in an exam. Overall attempt time 1.5 to 2 minutes should be good enough. What are the last two digits of 73 raised to power 125? Now, if you look at 73 raised to power 125, any number ending in 3 can be raised to a power so that it ends in 1. So I'm writing 73 raised to power 125. We know that 3 raised to power 4 is 81. So I need a power of 4 here. So I write this as 73 into 73 raised to power 124. This can be written as 73 into 73 raised to power 4 raised to power 31. 31 into 4 is 123. Now we look at the last two digits of 73 raised to power 4. So for that I multiply 73 and 73. 73 into 73 will end in, this is a 9, 1, 29. Just looking at the last two digits, this is 73 square. The other 73 square will also end in 29. And we know that 29 into 29 ends in 841. So ends in 41. 29 into 29, the last two digits of the product. The last two digits of this will be same as 73 into 73 raised to power 4 ends in 41 raised to power 31. This will be the same as 73 into 4 ones are 4. The last two digits of a number ending in 1 is simply 1 in the end. Before this, we write the unit digit of the product of the tens place of the base multiplied by the ones place of the power. 4 ones are 4, so 41. 73 into 41 is what we get. We multiply these two to try and get the answer. 73 into 41 will end in 73, 41. 73, suppose these are 12. This will end in 93. So the last two digits here will be 93. I am calling it a moderate level of difficulty question because there might be calculation steps involved, but the process is very repetitive. And when you're solving this process, should not take about more than 2 to 2.5 minutes. Which of the following has the maximum value? 170 factorial to 130 factorial, 115 to 150, 214 to 60. Let us compare these two. Now, if we compare these two, in this case, both will have 150 factorial common. So what? Suppose if this is x, this is y. This is x, this is y. So we can write these two x by y as when we divide 170 factorial by 150 factorial, we'll be left with 151 into 152 into 153 and so on till 170. That is what will remain from 170 factorial. When we divide 130 factorial by 150 factorial, we'll be left with numbers which will be in the 130 factorial cancelled, 131 into 132 and so on till 150. As we can see, for each number, 151 is greater than 131, 152 is greater than 132 and so on. So A will be greater than B. If we compare A and B, again, if we take this as Z, x upon Z, 170 upon 240 factorial, we'll be left with 171 into 172 into 173 up to 240. And 130 into 60 will be left with 61 into 62 into 63 up till 130. So here we have 70 terms. Here also we have 70 terms, but clearly 71 is greater than 61, 72 is greater than 62, and so on. 172 is greater than 62, and so on for each term. Therefore, the denominator is greater than numerator. So z will be greater than x. Now, if we compare C and D, simply if we divide them, 240 or 300 factorial by 240 into 60. This can also be written as 300 C 240, which is a value greater than 1. So 300 factorial is greater than 240 into 60. But if we divide, here we'll be left with the numerator 241 into 242 into 243 and so on till 300 divided by 60 into 61 into 62 and so on. Sorry, divided by 60 factorial is what is left, divided by 1 into 2 into 3 up to 60. As we can see, each term of the numerator is greater than each term of the denominator. And therefore, the numerator is larger than the denominator. So the largest term here will be D300. I checked for all the terms one by one, and therefore the attempt time increased. But I think here it should be obvious. The larger factorial we take, the larger is the answer, because in all of these cases, the sum was 300. So the largest factorial, when we take off a number, that is when we'll get the largest value. Find the highest power of 24 and 150 factorial. 24 is 8 into 3 or 2 cube into 3. So we'll have to look for powers of 2 and 3 in 150 factorial. For powers of 2, we start dividing 150 by 2. So 150 by 2 is 75. 75 by 2 is 37. Greatest integer function. 37 by 2 is 18. 18 by 2 is 9. 9 by 2 is 4. Greatest integer function. 4 by 2 is 2. 2 by 2 is 1. So if I factorize 150 factorial, the highest power of 2 here is 9 plus 1, 10. 16, 16 plus 8, 34, 34 plus 37, 61, 71, 37, 34, 71, 71. 71 plus 75 is 146. We have to divide this by 2 cubes, so we can write this as 2, 146 is not divisible by 3. 16, 11. 144 is. So 3 into 144. 48 into 2 raised to power 2. 48 into 3 will be 144 plus 2 is 146. Into 3, we look at the power and then whatever number n is remaining. Now, if you look at 3, 150 by 3, if we're checking for power of 3 in 150 factorial, 150 by 3 is 50, 50 by 3 is 16. 16 by 3 is 5. 5 by 3 is 1. So 66 and 672. Now, if we have to divide 150 factorial by 24, basically we are dividing 2 raised to power 3, which is 8 raised to power 48 into 2 raised to power 2 into 3 raised to power 72 into n upon 8 into 3. Clearly, the limiting factor is for 8, which is 48, and therefore the highest power of 24 that will divide 150 factorial will be 48, because once 8 divides it 48 times, suppose you're finding out the value small n, anything which is more than 48 will not divide the rest of the part. So the maximum value that n can take is 48. For 3, it can go up to 72. Since the limiting number is 48, so answer is 48. Again, if we have done factorial, this should not be a difficult question to solve. The only reason is there are some calculation involved. So I'm saying a moderate level of difficulty question. And therefore, if you look at the overall analysis for this test, as mentioned initially, this test was easy in terms of level of difficulty. 18-20 minutes should be good enough. And 7 questions net correct at least would give you a good percentile or a 95 plus percentile. Again, the basic requirement for these tests is that we've gone through the topics. If I have not done factorials, if I have not done base systems, I'll not be able to attempt these questions. Once the topics are done, that is when I'm saying 7 questions should have been attempted in this test, which will be those 7 questions for me. I would have gone with questions 1, 2, 4, 5, 7, 9, 10. Which are these? Definitely doing this simple application of a decimal system. Doing this as well. Base 2 to base 8 is a common or something that you would pick up if you're doing base. This could have been looked at because you'll have to take the values. Confusion can happen. This was a standard 7 question where 7 base is easy or cyclicity is easy. Should have done this. This again would be a question where you can take a call that it is there is very high chances of getting confused or a calculation mistake might creep in or a value might be left out. So might have left this in the exam. Definitely doing this standard process. Uh, Again, you might take a call on this question because there is some calculation involved. And unless you have done 2-digit cyclicity, this might not be something that you attempt in the exam. Definitely doing this, a simple observation will give you the answer for this question as long as you understand factorials. And again, this is a standard process, should be attempted in the exam. So for me, my attempt for this paper will be 1, 2, 4, 5, 7, 9, 10.